All right, so we're moving on to the next section of testing. Just a heads up, I do not feel the greatest. I have a headache and just letting you know, but let's see how this section goes. Controlling how tests are run. Just as cargo run compiles your code and then runs the resulting binary, cargo test compiles your code in test mode and runs the resulting test binary. You can specify command line options to change the default behavior of cargo test. For example, the default behavior of the binary produced by cargo test is to run all the tests in parallel and capture output generated during test runs, preventing the output from being displayed and making it easier to read the output related to the test results. Okay? So what they're saying here is, by default, when we run cargo test, one, they create a test binary for us that seemingly compiles both our source code and our test code, and then runs the test. But also, these tests run in parallel, and the output for each test is captured during the test run, and then later on, when everything else, I guess, gets gathered, put in that one output that we see when we run cargo test. Some command line options go to cargo test, and some go to the resulting test binary. To separate these two types of arguments, you list the arguments that go to cargo test, followed by the separator, --, and then the ones that go to the test binary. Running cargo test --, help displays options you can use with cargo test, and running cargo test --, space --, help displays the options you can use after the separator --. So what they're saying here, given that I understand it correctly, is that when we pass arguments to cargo test, we have the option of passing it directly to cargo test or to the test binary. And the way you separate those two arguments is with this --. So they have the example with cargo test help, which is a option that goes directly to cargo test, and then they have cargo test --, space --, help, which should be an argument that goes to our test binary. Let's test that out just to verify. And let's bring up our editor. First, let me make sure this still runs. It's been a week. Cargo test failed. Meh. Cargo test --, help. And let's see what it wrote out. Wrote out quite a bit. Wrote out a lot, actually. Ooh. All right. Yeah, let's make this big so we can just see it. So cargo test help execute all unit integration tests and build examples of a local package. Oh, I should run it again. It didn't resize. Here we go. This is easy to read. Execute all unit and integration tests and build examples of a local package. And then here are our options. We have quiet, lib, bin, example, examples, doc, that's benches, features, okay, frozen, args, and then, so what are they saying down here? The test filtering argument test name and all the arguments following the two dashes, --, are passed to the test binaries and thus to libtest, Rusty's built-in unit test and micro benching framework. If you're passing arguments to both cargo and the binary, the ones after -- go to the binary and the ones before go to cargo. And this is exactly what the chapter is explaining, which I guess is also explained here if you just wanted to read it from cargo test itself. All right, let's go back to the doc. Ooh. Running tests in parallel or consecutively. When you run multiple tests, by default they run in parallel using threads. This means the test will finish running faster so you can get feedback quicker on whether or not your code is working. Because your tests are running at the same time, make sure your tests don't depend on each other or in any shared state, including a shared environment, such as the current working directory or environment variables. Alright, so what they're saying here is just some best practice for when you're writing tests in parallel, or just writing tests in general. One, test should be like a unit, and they should not depend on any other units within it. Yes, you can have setup. Yes, you can have teardown. Those are expected. However, the individual tests themselves should not depend on another test. And the reason for that, at least especially in Rust, is that these tests are running in parallel. As in, we do not know the ordering of which test is going to run first, and as such, we can't depend on ordering, which in result means that this test cannot be dependent on a previous test. Moving onward. For example, say each of your tests runs some code that creates a file on disk named test-output.txt and writes some data to that file. Then each test reads the data in that file and asserts that the file contains a particular value, which is different in each test. Because the tests run at the same time, one test might overwrite the file between when another test writes and reads the file. The second test will then fail, not because the code is incorrect, but because the tests have interfered with each other while running in parallel. One solution is to make sure each test writes to a different file. Another solution is to run the test one at a time. So this is a really good example of what they're trying to illustrate. So they have this test, right? Well, they have a series of tests, and they all depend on one file. And each of these tests writes to that file and then reads the value from it. Now, because the tests are running in parallel, one test could be writing to it while another one is reading from it, and as such cause some confusion, and thus tests will start failing. So in this scenario, how would you go about fixing that problem? Here they illustrate two possible solutions. One is to have each test write to a different file, making sure that no test can interfere with another test. So another solution is to have the test run one at a time, just consecutively, so that when one test starts, the other test is already finished. It goes, so one test starts, it ends, the next test starts, and then it ends. If you don't want to run the test in parallel, or if you want more fine-grained control over the number of threads used, you can send the test threads flag and the number of threads you want to use to the test binary. Take a look at the following example. Okay, so if you want to run all the tests in one thread, and if we're running all the tests in one thread, that means they're running sequentially. Then we can use this syntax, right? We have the dash to make sure that we're passing this flag, the test threads flag, to the testing binary, and then we say we only want one thread, and that's one thread of execution. We set the number of test threads to 1, telling the program not to use any parallelism. Running the test using one thread will take longer than running them in parallel, but the tests won't interfere with each other if they share state. Showing function output. By default, if a test passes, Rust test library captures anything printed to standard output. For example, if we call printline in a test and that test passes, we won't see the printline output in the terminal. We'll see only the line that indicates the test passed. If a test fails, we'll see whatever was printed to standard output with the rest of the failure message. Okay, so what they're saying here is that, so we know that when the tests are running, right, all the output of the test is being captured by Rust. However, that output is only displayed if the test fails. By default, that's the default setting. We can probably change that, but by default, if a test fails, then things that you printed to standard out would be displayed. If it passes, you won't see any of that. You only see that the test passed. As an example, listing 11-10 has a silly function that prints the value of its parameters and returns 10, as well as a test that passes and a test that fails. And this is something we can write out. Make this smaller. Test. We have a function called print and returns 10. It takes a I32 and it's returning 10, so let's say I32. There's the macro print line. I got the value. And then returns 10. Then in our test, get rid of this. Function, this test will pass. The value equal print and return 10, pass in 4. Assert equal 10 value. Put the attribute test function. This test will fail. The value equal print and return 10, pass in 8, and assert equal 5 in value. And it's going to fail because we're just returning 10. This is pretty explicit. And then down here, let's run cargo test. So we got one pass, one failed, right? Let's start from the top. Cargo test. We got our warning for dead code because we're not using it in our source code, just in our test. Down here we get failures, and we see that this is the print line. I got the value 8, which is printed in the function. So that got printed to output and then captured. And then here's the rest of the failure message of the test. But as you can see, the output for the test that passed, which we passed in 4, did not get displayed here. Did not get displayed anywhere here. Okay. When we run these tests with cargo tests, we see the following output. One passed, one failed. Message, this is exactly what we got. Note that nowhere in this output do we see I got the value 4, which is what is printed when the test that passes runs. That output has been captured. That output from the test that failed, I got the value 8, appears in the section of the test summary output, which also shows the cause of the test failure. If we want to see the printed values for passing tests as well, we can disable the output capture behavior by using the no capture flag. And it looks like this flag is being passed to the test binary. So let's test that out. No capture, one word. Well, gotta spell it correctly. Cool. So yeah, as we can see, the test ran, said running 2 tests. And we get I got the value 4, which is printed from our passing test. And it says that test passed. That's right here. It's in sequential order, right? Then I got the value 8, which is printed here from the test that failed. It says it fails. It says it fails here. And then all this output is what was previously in this section, failure section. So we scroll up, we can see that that is right here. Failures, all that is right here. That section now is empty because we just passed in a no capture flag seemingly. And then we still get the list of failed tests. Okay. Note that the output for the test and the test results are interleaved. The reason is that the tests are running in parallel. As we talked about in the previous section, try using the test threads equal 1 option and then no capture and see what the output looks like then. Ooh. So I know what they're saying here, but I'm not sure if we saw this issue. So what they're saying is that our tests by default are running in parallel. We have 2 tests. And because we have 2 tests and they're printing to 1 output screen, 1 standard out, then it's possible that the messages that are coming through, like the print lines, get mixed up when they get printed out here. Because there's no ordering. There's no this test going first, this test going second. They're just printing at the same time. Race conditions, more or less. However, if we should see something different, or we should be able to fix that by passing in the test threads equals 1 option. So let's try that. I think that's on the binary side, but we'll find out. Oh, so the output is different. Okay. But it's not much different. So as we can see here, we have the running of the 2 tests. The test that failed ran first, and we got a ... and then we got the print line that was printed out the screen, and then we get the rest of the standard error failure message, right? And then here we get the test that passed, and we get a ... and then we get their printed out lines. So this is cleaner to read and easier to read. That's one thing that could be of note. But the information is more or less the same, with the exception of, so they changed the formatting a little bit. So if you go up here, right, we have this is the test that passed. We ... we have an OK. So the ... has always been there, and here's ... failed. Here we have ... output, and then last we have the whether it passed or failed. ... print output, pass or failed. Okay, that's different. Running a subset of tests by name. Sometimes running a full test suite can take a long time. If you're working on code in a particular area, you might want to run only the tests pertaining to that code. You can choose which tests to run by passing cargo test the name or names of the tests you want to run as an argument. To demonstrate how to run a subset of tests, we'll create 3 tests for our add_to function, as shown in listing 11-11, and choose which ones to run. So now we have a new test. Let's make this smaller. New function, public function add_to, I32, and the function is a+2. Pretty straightforward. Now we need to write 3 tests. The first test is add_to and 2. Add_to and 2. Assert equal 4. Add_to 2. The next test is add_3 and 2. Add_3 and 2. Assert 5. Then add_2 to 3. Okay. And the last test is 100. Cool. Assert equals 102. Add 2 to 100. So you have 3 tests. Let's make sure they run properly. Sorry, let's make sure they run and pass. Go test. Let's look at our output. 3 tests, they ran, they passed. All right. If we run the test without passing any arguments, as we saw earlier, all the tests will run in parallel. Running single test, we can pass the name of any test function to cargo test to run only that test. And they have the example of 100. So cargo test, passing the name 100. And only that one test ran, as you can see here. Only the test with the name 100 ran. The other 2 tests didn't match that name. The test output lets us know we had more tests than what the command ran by displaying 2 filtered out at the end of the summary line. So right here, it's kind of jumbled, but in the summary line, where did it go? Here. I can write it again so it's not cut off. We have 2 filtered out. This is telling us that there were 2 other tests that were filtered out and did not run during this test run. Okay, that's good to know. Ooh, they go hand in hand. That's kind of cool. We can't specify the names of multiple tests in this way. Only the first value given to a cargo test will be used. But there is a way to run multiple tests. Filtering to run multiple tests. We can specify part of a test name, and any test whose name matches that value will be run. For example, because 2 of our test names contain add, we can run those 2 by running cargo test add. Test that out. And here we have running 2 tests. Here are the 2 that ran, 1 filtered out. This command ran all the tests with add in the name and filtered out the test name 100. Also note that the module in which a test appears becomes part of the test name. So we can run all the tests in a module by filtering on the module's name. I see. So this module is test seemingly. Let's go back here. So the module is test. So if we filtered on test, we should get all the tests running. And as you can see, test is in the name, and 3 tests ran, and 0 filtered out. So we have different modules of tests. Let's say one test module is, I don't know, add, and the other module for test is subtract, and we did cargo test add, then all of the add tests would run. That's good to know. Ignoring some tests unless specifically requested. Sometimes a few specific tests can be very time consuming to execute, so you might want to exclude them during most runs of cargo test. Rather than listing as arguments all the tests you want to run, you can instead annotate the time consuming tests by using the ignore attribute to exclude them as shown here. And they did that by putting ignore right there. So let's do that to the test that has 100 on it. It says it's ignored. We run this, and we see that 3 tests are running, 100 was ignored. These 2 are okay. And we have 2 passed, 0 failed, 1 is ignored, 0 measured, which is I believe for benchmarking, and 0 filtered out. Okay? So after the test attribute, we add the ignore attribute line to the test we want to exclude. Now when we run our test, it works, runs, but expensive test doesn't. And we saw that output. It just says it's ignored. The expensive test function is listed as ignored. If we want to run only the ignore test, we can use cargo test -- space -- ignored. Let's verify that. Ignored. 1 test ran, 2 were filtered out. That works. By controlling which tests run, you can make sure your cargo test results will be fast. When you're at a point where it makes sense to check the result of the ignored test and you have time to wait for the results, you can run cargo test space -- space -- ignored instead. And that is the end of this video. I hope that was useful, hope that was entertaining. If you liked it, please subscribe. Aside of that, peace.